Alright, so section 5.1. We're in chapter 5 already. I like chapter 5. It's a little bit, it gets into more of, the heart of algebra, which is dealing with lines and slopes and rates of change and all that kind of stuff. So let's begin our conversation today by talking about the rate of change, okay? The rate of change is the same thing as slope. It really is the same thing as slope. They are the same ideas, except rate of change can pertain to other things besides line. That's why we talk about rate of change, okay? So there's 5 boxes for us to talk about. So let me give you the definition for us that we're going to work with, okay? So the rate of change, by definition, so we'll talk about it. Rate of change is defined to be this. And I like the way the book describes it for us. It's the change in the dependent. By the way, do you guys know that the triangle is the delta symbol? And delta means change in, so you're going to see me use that. So that's the delta symbol, it means change in. So it's the change in the dependent variable. The change in the dependent variable, and the dependent variable in algebra is most often y, divided by the change in the independent variable, and that for us is x. So it's the change in the dependent over the change in the independent, and that's how they talk about rates of change. So the change in y over the change in x. Alright, so this is going to be our working definition of what we mean by rate of change. Notice that the rate of change is what? How is it represented? Is it a sum? Is it a difference? Is it a quotient? Is it a product? What is it? It's a quotient, right? And we learned earlier in the year, basically 3 days ago, because it's summer school, we learned that quotients can be represented as ratios. So the rate of change is nothing more than a ratio comparing two quantities, right? The dependent to the independent. So far, so good? We on board? Okay. Okay, so let's begin with this example by taking a look at a table, right? The table is titled Distance Marched. So we have the distance that a marching band has marched over time, and the question is the rate of change in distance with respect to time constant? Is the rate of change distance with respect to time constant? That's what we're looking at in this particular problem. Okay. And then what does the rate of change represent for us in this particular problem? So after 1 minute, how far has the marching band marched? 260 what? Feet. After 2 minutes, how far has the marching band marched? After 3 minutes. And after 4 minutes. Okay, so what we need to do is we need to calculate the rate of change for all the values that we have to determine whether or not it is constant, okay? So for us, remember the definition that we're using. The rate of change is equal to the change in the dependent over the change in the independent. So now which one depends on which? Does time depend on distance, or does distance depend on time? The distance that they travel depends on how much time. So the distance is on top, and then the time is on the bottom. So, okay, let's do the change, and let's look at this one. So we're going to take this. We're going to take 520 minus 260. That's the change in distance, right? So that's the change in y variable over the change in x variable. So the change in x variable is going to be 2 to 1, 2 minus 1, right? So when we plug all that through, 520, that's 260. 260 divided by 1. Okay, that's what we have. So what does that represent? Not the slope, right? There's not, this is a marching band, so there's no line here. We're talking about rate of change. This is why we talk about rate of change. What's that? That's right, how much distance they have covered per minute. So between those 2 minutes, or between that minute, between minute 1 and 2, they went an average of 260 per minute. Okay, so let's do it again. We have to do this one let's do it for this part of data. So let's do change in y over change in x. So that's going to be 780, take away 520, all divided by 3, take away 2. Okay, 780 take away 520, how much is that? Also 260 divided by 1. So what does that represent there? Right, so the rate of change for that one, right, it's 260 over 1. This is looking good because they're the same so far, right? Okay, now let's take a look at the last piece of data. So change in y over change in x. Again, we get 1040 minus 780, all divided by 4, take away 3. So we take about that data right there, 4 take away 3. So again, what do we get for this? We get 260 over 1. So because we are getting the same rate each single time, the rate of change is constant, and it equals 260 feet per 1 minute marched. Does that make sense to you? So in this case, the rate of change is constant for us. Here's a question I have for you, though, to do this. Does it matter which, like, do you get the same rate if I chose 2 different data points? Would I get the same rate? Like, for example, if I chose that one and that one, would I get the same rate? Yes or no? What do you think? Someone says no. Should we do it? Yes or no? We do get the same rate? Why? Let's do it. Why don't we just do it right now and see? Okay, let's take those 2 and try. So if we just blindly took whatever, so this would be 1040, right? Take away 260 divided by 4, take away 1. Well, how much is 1040 take away 260? Help me out. How much? 780, and we're going to divide that by 4, take away 1, which is 3. What do I get? I still get 260 over 1. So it is constant. It is constant. Okay. Okay, so rate of change, I told you that rate of change and slope are basically the same thing, but we use the word rate of change when we're talking about 2 quantities out in the real world, or anything that we were talking about that has to do with a table or data. We talk about the word slope when we're talking about lines, all right, lines in the plane, okay? So for us, I'm sure you all know what this is, or at least you've all seen this before, right? How do we calculate what slope is? Well, remember, it's the same thing that we had before. We said it was the change in y over the change in x, right? So how do we calculate what is the change of y and what is the change of x? What does that mean visually on the graph? Anybody know? Yeah, it is the same thing as rise over run. Okay, we're on the right track. It is rise over run. Yeah, there it is. Okay, what the heck does that mean? What is y2 minus y1 over x2 minus x1? What does that even mean? Yeah.
Isn't it taking 2 data points from a graph and calculating the slope and their values?
Yes, 2 data points from the graph and calculating it. So let's actually talk about where this comes from. Okay, I do want to show it to you. So do yourself a favor, the best you can, and make yourself any old generic coordinate plane. Okay, kind of like this. Okay, kind of like that. And then let's give ourselves 2 data points. Okay, let's give ourselves a point there, and let's give ourselves a point there, because I want you to understand where this comes from and why the slope formula is what it is. Okay. Draw a line the best you can that connects those 2 points right there. Okay, so there we go. We have these 2 data points and we have a line. Okay, good. Now we're going to call this point, since this is my x-axis, this will be my first x point. Is that fair enough? Yeah. And then underneath my second point on my x-axis, this is my second x point. So far, so good. You guys good with that part? Okay, now on the y-axis, okay, this is my first y point, and this one up here is my second y point. So if I was gonna actually label this point here, this point would be x1, comma y1. That would be this point here. This point up here would be x2, comma y2. So regardless of what point they are in the plane, they would just be those generic points right there. Okay, so the change in y. Let's talk about this part right here, the change in y. The change in y is the difference between y2 and y1. Well, that's located right here, right? If I measure that, that's this change right here. So that distance right there is called, the way that we calculate that, that's y2 minus y1. That's that difference. That's the change right there. Notice that it's the same distance if I move that highlighted bar over to where it actually lines up on y sub 2. So that's the same distance right there. Well, the same idea works for the x, right? If I want the change in x, well, it's that minus that. That's the change in that. So if I bring that up, I can see that it is right there. So since the slope is a ratio of the change in y over the change in x, that's where the formula comes from. We can see that we get y2 minus y1 over x2 minus x1. So this is our slope formula for any two generic points in the plane. So let's talk about this. So everyone actually close your eyes for 1 second, okay? Close your eyes, like look away for a second, okay? So here we go, let's see here. Oops. Oh, wait. Okay, now look back at the screen. Okay, so I had to make a graph. I didn't want you to see it. All right, so check this out. I have this graph here, and I can do a lot with this graph. I can do whatever I want with this graph. Okay, here's the task I have for you guys. I want you to do, okay? How do I calculate the slope of this particular line right here? What do we do? Yeah, what do you think? Yeah.
I was stretching.
Oh, you're just stretching. Will, yeah. What do you think?
You can find 2 points on the graph that cross the corner.
Okay, give me a point that you think is on here. What point do you think is on here?
Let's go with -3, 3.
Negative 3, comma 3. Is that what you're saying, like that? So here, if I put that point on the graph, yep, that point is on the graph. Did you guys see that? Okay, give me another point that's on the graph. Yes. -6, 1. Okay, is that point on the graph as well? Let's put that point. Yep, that point's on the graph too. I can see it down here. It's over there. Okay, now how do I calculate the slope then? Yes, Evan. Oh, I only need 2, right? I only need 2 points up here. Yeah. Okay, Will, what do I do?
You connect the 2, like you go up and
I go up. So what's that distance right there? It's the same distance over there, right? It's the same exact distance over there. Okay, what's this distance right here? Notice it's the same distance right there. So this is my delta y, and this is my delta x. You guys see that? Okay, so what's the change in y? How far up did we go? 2 units, right? So, because we did, this is 2 units here. And then how far over did we go for the x? We did 3 units. So what is the slope of that line? What should it be? So we're thinking that's, and then we use, of course, we use the letter m for slope, right? So we think that the slope of this thing is 2/3. And you know what? You're absolutely right. There's the equation for that particular graph right there. Okay? Nicely done. Okay. Close your eyes again. Okay, take a look at this graph here. I just made a new graph. All right. What do you want to do for this one? Can I zoom out a little? Sure, dude. Is that what you want?
Oh, no, that's way too far. Thank you.
So you can see the y-intercept? Like that? Is that what you want? Yeah. Okay. All right, I'm with you. So, what do you want to do? You think 0, 1? Let's see if 0, 1's on there. 0, 1. Let's see, is that point on there? Yep, that point's on there. What else is on there?
Can you zoom out a bit?
Zoom out a bit? Is that what you want? -4, 2? Let's see here. -4 and then 2. Is that point on there? Nope, that point's on there. Let's erase that one. 2, comma, -4? Is that on there? That point is not on there. Do you guys see another point that could be on there? Whoa, where'd my line go? Ooh, what do you guys think? Can we find one? There's gotta be one somewhere on here, right? Where'd it be?
I just saw 2, but
You did? Am I moving too fast?
goes about, yeah,
Okay. Where do you want to go? Down?
yeah.
A little more?
Yeah.
So this point's not on there. Okay, what do you got?
1.2
-2.75. Did I get that right? Let's see if that point's on there.
No, it's on the line.
It's on there? It doesn't look like it's on there.
On there, though. Look at it. It's on there.
1.2.
Thing is wrong.
No, what?
Nope, it's not on there.
Okay, then can you zoom in like all the
Can you
way?
zoom
Yeah, actually,
in?
no.
Can you zoom out? Yeah, zoom like all the way out.
No, zooming out is like
Zooming out like
Be
this?
like a general.
just zooming out. You won't know what it is.
There, right there.
Okay, let's see about that one. You guys say 35,
It's gonna be
comma, negative 50. Let's see if that point's on there. Oh, what do you guys think? Is that on there? Okay, so you think we found 2 points that are on there?
Oh my god.
Okay, what are the 2 points that we found?
Cross out the 1.2.
Yeah, we can cross that one out. We don't want that one. Okay, let's get rid of that one. Okay, so there we go. We think those 2 points are on there. Okay, go for it. See what you come up with.
D over 35.
I have 1 vote for negative 7/5. Anybody else get the same thing? Okay, check it out. Here's the equation. Y equals negative 7/5. You guys are right. -1. That's very good. You guys absolutely perfect. Okay, I have another task for you to do. Okay, I'm going to give you 2 points. All right. The first point that I'm going to give you is 4, comma, negative 3. And the next point that I'm going to give you is 4, comma, 2. All right. So I've given you 2 points. I'm going to go ahead and throw them on a graph for you right there. Ooh, very nice. Okay. All right. Now, your task. Tell me the slope of the line that goes between those 2 points. Ready, set, go. All right. So, you guys are telling me no slope and then vertical line, right? So, what line would that be? So, if we graph the line x equals 4 really quickly, that's the line that we get for x equals 4, right? Okay, it's something we have to talk about here. You guys are telling me that there's no slope. I think that that's not what you're trying to say, because if there was no slope, then I would say that this line that I just gave you right there, that black line, I would say that line has no slope. So the line that we're talking about, so let me get rid of this one, all right? Let me get rid of that one really quickly. The one that we're talking about is undefined, okay? The right word to use is undefined. So let's go back to our notes here and let's plug that in. So we have this. We have to add to our definition right here of slope. We have to say that x sub 2 minus x sub 1 is not allowed to be 0. Is not allowed to be 0. I really want you to make the connection between the fact that if the x2 minus x1 is 0, then we call that an undefined slope. All right? Why do we call it an undefined slope? Because look, if I look back at this graph here, the change in x, right, the actual change in x, well, 4 minus 4 is 0. So the change in x is 0, therefore we have an undefined slope, okay? So slope can either be positive, negative, it could be 0, or the word undefined. What does it mean if my slope is 0?
It's a horizontal line.
It's a horizontal line. The change in y is going to be 0. All right? But if I have a change in x that is 0, then I have an undefined slope, and that's the reason why we have that there, okay? All right, let's talk about what slope could actually look like, all right? I told you that slope could be positive. Slope could be positive. So how do I tell if the slope is positive? What determines whether or not slope is positive on the graph? Alice? If the line's going, you're pointing in a direction. Yes, okay, if the line is going up from left to right, then we have a positive slope. That tells me if it's positive. Okay, I told you that slope could be negative, right? So what does it mean for a negative slope? What would that look like? If the line is going down from left to right. Now we read a graph just like we read a book, right? Left to right. So that will give me a negative slope. Okay, I also told you that a slope could be 0. The slope could actually be the number 0. What would that look like for you? It would be a horizontal line that looks like this, right? Any horizontal line that looks like that. And then I also told you that the slope could be undefined, right? And we actually use the word undefined to state the slope is undefined. If what? What would it look like? What would the picture look like for that? It would be a vertical line, yes, absolute vertical line. If our slope is vertical, we have undefined. So slope is allowed to be these 4 things, you guys. A slope could be positive, slope could be negative, slope could be 0, or slope could be the word undefined. Okay, I'm giving you 2 points. 7, -5, 11, and 2. Please tell me what the slope is using the slope formula. Using the actual slope formula. Using the slope formula, we say y2 minus y1 over x2 minus x1. So it should be 2 minus a -5 over 11 take away 7. So that translates to 2 plus 5 over 11 take away 7. So what do you guys get for the slope for this thing here? 7/4. Positive, negative, undefined, or 0? This is a positive slope, and you guys are good to go. All right.